So today we have to discuss about parallel network. Parallel network. In this parallel network, there are a lots of combinations: RL network, RC network, RLC network. So suppose we are discussing for started now. Yeah. So we are discussing for RL network. So see, this is your R, this particular is your L, and so this is your V of t. Okay, particular I current is moving in this. Suppose this particular branch current is IR, and this I am taking as a IL. So what is the, if you will apply the KCL, so I phasor will be equals to IR phasor plus IL phasor, right? So here the all branches are in parallel only. So the voltage across this R is V of t only, and the voltage across this particular L is V of t only. Okay, if I am assuming V of t is equals to Vm sine omega t, so and yeah, so if you know that v of t is equals to Vm sine omega t, if you will apply the nodal analysis, this is your reference point, this is your V of t, and for L we can write it like this, j omega L, okay, in the form of resistance, reactance. So what will be the current of IR? IR is equals to Vm sine omega t by R. And what will the current of IL? Same voltage is there, so Vm sine omega t and
J omega.
divided by j omega L. Okay, so these things I am assuming as Im sine omega t, and this particular IL can be assumed like this, Vm by omega L.
Sir,
Yes.
sir, Vm sine omega t. Sir, it's like a formula, was sir.
See, this is your AC voltage, na? So in a AC, what is happening? It will go as a positive cycle, negative cycle, positive cycle, negative cycle.
So, okay, so it's a AC, so it gives sinusoidal, so that formula will come, sir.
Yeah, that's why we have written. It's a trigonometric functions. For a sinusoidal wave, we have to use Vm sin omega t for AC signal. Okay. Okay.
Yeah, sir, yeah.
So that's why we are using like this. So Vm by omega L sine omega t, and here j is 1 at an angle 90 degree, the meaning of j. So this, if Vm by omega L, and this if it will go upside, then what it will become, sine omega t minus 90 degree. Okay, wait join. So these things will become Vm by omega L sine omega t minus 90 degree. So
Sir, why minus 90 degree?
because there is a polar form, means like a, see, 1 at an angle A divided by 1 at an angle B, or some A is there and some B is there, it's having some angle, the overall result will be AB at an angle A minus B. Okay, so here means the angle we are writing in the sine form. Okay, so these, if we'll shift this at the upside, then that's why this is becoming as a minus 90 degree. Okay, so Vm sine omega t, this is what omega t is representing, some angle, your angle. This is your numerator part. And listen, and let me tell you one thing, you can also write, I repeated these things so many times, Vm sine omega t, you can write like this, Vrms at an angle 0 degree, because with the omega t nothing is added, nothing is added, so assume it's a 0 degree. And here j omega l can be written as omega l at an angle 90 degree. So Vrms by omega l, if it will go upside, it will become minus 90 degree. Now if you want to change this again in the form of this will become Vm sine omega t minus 90 degree divided by omega l. Is this clear? This Vrms means,
Yes, sir.
see, if you have a Vm sine, let me tell you, this is your sinusoidal curve. Okay, this is your Vm, this is your minus Vm, from peak to peak it's representing Vm. So this curve is Vm sine omega t. If you want to write in the form of a phasor, so Vrms with omega t nothing is added, so it's a 0, so Vrms at an angle 0 degree. What is Vrms? Vrms for a sinusoidal wave, Vrms is Vm by root 2. We'll see how this value is coming, root mean square, why this is coming. So if you want to write Vm sine omega t in the polar form, in this form, in the phasor form, you have to write like this, Vrms at an angle, what the angle is added, so 0 degree, and the meaning of j is 1 at an angle 90 degree, and you are having a downside omega l into j, so it's a j means 90 degree. So if it will go upside, it will become Vrms divided by omega l at an angle 0 degree minus 90 degree. Okay, so Vrms by omega l at an angle minus 90 degree. If you convert this Vrms again in the Vm form, then Vm sine omega t, now the angle is minus 90, so you have to divided by omega l. Is this clear? Is this clear?
Yeah, no.
Anika, is this clear? Priyanka?
Yes, sir. May I audible?
Yeah, you are audible. Okay, so please watch the previous lecture perfectly, you will get it, because I discussed these things
Yes,
earlier.
sir.
Okay, so means the
Okay,
things.
sir. I will watch it.
Okay, so see, so for a parallel network, we having a RL, RC, RLC. So we are seeing for RL network. So R is connected parallel with L network. Here V of t is will be the voltage of R also and L also. L can be written as a j omega L. The current for R will be IR. The current for L will be IL. What will be the current of IR? IR will be whatever the voltage across this will be divided by this. So Vm sin omega t divided by R. So we are getting the current across this as a IR is equals to Im sin omega t. Vm by R I have considered as Im. And what about IL current? IL will be Vm sin omega t divided by j omega L. So we are getting the result, because in the downside the angle is 90 degree. If it will shift to upper side in a numerator, it will become minus 90 degree. So it will become Vm omega L sin omega t minus 90 degree. So we are getting a 2 current. Yeah, we are getting a 2 current. So what is the value we are getting? Actually we are getting IR is equals to Im sin omega t, and see IR is equals to Im sine omega t. This can be written as IRMS at an angle 0 degree, and you are getting also IL is equals to Vm by omega L. So I am taking this one as, okay, and Vm by omega L sine omega t minus 90 degree. So this value IRMS 1 we are taking, and this value it will be IRMS 2 at an angle minus 90 degree if you will convert this in the form of this. So overall current will be I phasor will be Kirchhoff's law, IR plus IL. Okay, so overall I current will be IRMS 1 at an angle 0 degree plus IRMS at an angle minus 90 degree. Okay, so if you'll draw the phasor diagram, like we have a reference, we have a reference. So we consider the voltage V of t is equals to Vm sine omega t. So what is the meaning? It having a angle 0, that's mean it will be neither lag nor lead, it will be on the reference point only. Okay, what about your this is okay, and you are getting your IR of t is equals to Im sine omega t only. So your IR will also be on the reference only. IR. What about IL? IL is Im2 sine omega t minus 90 degree. So it's getting lag by 90 degree. So 90 degree lag. This is your Im2. Okay, now you have Im2 current and you have IR current. So Im2 plus IR will give you which current? Im2 plus IR will give you overall current. So your phasor will be like this, and wherever the IR means the resistance part will be there, you have to consider theta there. This is clear to everyone how I draw? This part is clear. Prasanna, is this clear?
Yeah.
So we are getting the things like this. So can anyone tell me what will be the power factor for this case? Cos theta is equals to base by hypotenuse.
Hypotenuse.
So cos theta we are getting, what is base? IR.
IR
And
by
what
I.
is by I? Okay. IR can be written like this, V IR is equals to V by R, na? V is equals to IR. So in the general form, so I is equals to V by R, and the voltage is same for both the cases. So V upon R divided by, and overall this is overall I, so I upon Z. So you will get cos theta is equals to Z by R for a parallel network, right? Cos theta you will get Z by R for a parallel network. This part is clear? This part is clear, or any doubt? Guys, this part is clear, or any doubt?
Yes, sir.
Okay, so okay, now can anyone tell me, means like see, suppose we have the network like this. This is your R part, this is your L part, overall connected to V of t. This is R, this particular is L. So both are parallelly connected. Okay, both are parallelly connected. In a parallel connections, what is the net equivalent? R1 R2 divided by R1 plus R2, right? So these two are
Yeah.
parallelly connected. So suppose this branch resistance and this branch resistance. So what it will give you? R1 R2 divided by R1 plus R2. But here this R2 is your XL. So what will the result will come? R1 into JXL, J omega L divided by R1 plus R1 plus R1 plus J omega L.
J omega L.
So these things we are getting. Okay. Now if I'll tell you one thing, means V is equals to IR. Okay. And V by I is equals to R. So what is I by V? Is equals
1
to
by R.
1 by R,
Sorry,
which is also known as conductance, G.
conductance. Yeah.
G is equals to 1 by R. Okay. Right. So we call this as a conductance. So we can write like this, na? This V is here and this particular V, all are the V only. So instead of R, we can make it like this. Your overall current is equals to I1 plus I2. Okay, this is I and this particular branch current is I1 and this particular branch current is I2. Phasor form. So what is I1? I is equals to V by R. And what about I2? V divided by J omega L. Okay. So this can be written as V 1 by R. V 1 by R we are taking common, and 1 by R means G. 1 by R means G. Now what is the meaning of 1 divided by omega L? And if J will go outside, it will become minus J. And 1 by omega L is your B. This B is known as susceptance. Okay. So B is nothing but 1 by omega L. We call it as a susceptance. Is this clear? Is this clear to everyone? And overall I is V is equals to I into Z. So overall I will be V divided by Z is equals to I. V by Z is I. So V by Z, you are getting V into G minus JB. This V cancel out. And 1 by Z, inverse of Z is what? Admittance. So you are getting Y is equals to G minus JB. Is this clear, or you need to repeat? Everyone, is this part is clear? We are getting admittance is equals to conductance minus J susceptance. Prasanna, is this clear?
Yeah, it's clear.
Okay. Vaishnavi, for you it's clear?
Yes, sir.
Priyanka, clear? Sharon, clear?
Yes, sir.
Okay. So see, now we having admittance is equals to G minus JB. So if you want to make in the form of a phasor we are representing, so I am assuming Y particularly with the angle theta, G there is a nothing, it's a real part, so G at an angle 0 degree and B at an angle
B at an angle minus 90 degree.
degree. Yeah. So how can you write like this? Means if you have a reference, so with respect to reference G will be drawn because it also have 0 degree. So This particular is your G. What about your BL part? Write this susceptance as a BL because we are making with respect to inductor, na? So BL. So BL will be lagging by how much? 90 degree.
Clockwise.
Yeah, clockwise it will go. So we are getting 90 degree BL part, and G plus BL, it will give you admittance Y, and this will be theta. So cos theta is how much? Base by hypotenuse. So base is G
G by Y.
B and hypotenuse is Y.
Y.
So cos theta can be written as well as G by Y, and we can write G as a 1 by R, and Y can be written as Y is equals to 1 by Z. So it will go. So we are getting cos theta is equals to Z by R. This part is clear?
Yeah.
Okay. If this is clear, then it's fine. So this is your parallel RL network. Now let's go for the parallel RC network. So same thing we'll do for parallel RC network also. Parallel RC circuit. Okay. Parallel RC circuit. So you have a parallel RC circuit. R is there, C is there. Okay. And you have some potential voltage you have assumed V of t. This is an AC circuit. This is I of t, and I am taking as a I phasor, and this particular current I am taking as a I1 phasor, and this particular current I am taking as a I2 phasor. So if V of t, we are assuming sinusoidal voltage, it's going like this. Your V of t is equals to Vm sin omega t. Okay, so this is parallel. So this is R, this is C. For capacitor, if you want to convert in the form of a reactance, what will be the value? Minus J by omega C, and R will be like this only. So this can be written as V at an angle 0. Assume these all, if I am writing, assume these things in a RMS value. Okay, this Vm and V is not same. Okay, assume this particular in a RMS value. So you know the voltage, V at an angle 0. So what will be the current? I1 current. V at an angle 0 divided by R. So I1 current is V by R at an angle 0 degree, or you can write like this, Im sin omega t. What about your I2 current? V at an angle 0 divided by Xc. This is your Xc only. So if you will convert this, V at an angle 0 degree divided by minus J and omega C by omega C. So I2 will go V omega C at an angle 0. This is minus J means minus 90 degree. So I2 will be V omega C at an angle 90 degree. Okay, so you are getting something like this. You got the I1 current as a V by R at an angle 0 degree. You got the I2 current V omega C at an angle 90 degree. And overall I is nothing but KCL I1 plus I2, I1 phasor plus I2 phasor. So what you guys are getting, I is equals to V by R at an angle 0 degree, and I2 is V omega C at an angle 90 degree, and this okay. So this, if you want to represent in the form of a phasor, this is your reference. What is your I1 current? V by R. This is your I1 current. So I1 current having angle how much? 0 degree. So this will be I1 only. What is your I2 current? V omega C, and this is leading Leading by how much angle? 90 degree. This is your I2. And both the summation of I1 plus I2 will give you I. Where will be the theta? Wherever the R is present. So R is present in V by R, I1 current. So this is theta. So what is cos theta? Cos theta is B by base by hypotenuse, I2 by I. Okay. So the value of a I2 is how much? V upon R. And the value of a I is, capital I is how much? V by Z. Right? V by Z. We'll get V by Z. So you are getting the same result, means V by Z.
Sir, I
Yeah, say. See, this particular I is there, na? So this is your particular I. So I is I1 plus I2. Okay. And V is equals to I into Z. So what is I? Z is equals to I is what? I is V by wait. I is V by Z. So that's why I have written V by Z. So V will cancel out. This Z will go upside and this will come downside. So Z by R we are getting. Same result we are getting. Okay. Now, if you will apply the
I2 is V omega C.
I2,
V omega C, sir.
but here see, okay, we are taking base na. This is I1. This will be I1. This will be I1. Okay. Base. Okay, I1 by I. Base by hypotenuse. So this won't be I2, I1 only. So result is same only. Cos theta is base by hypotenuse. So this was I1, not I2. So I1 by I. So I1 will get V by R and I will be V by Z. So we'll get the result Z by R only. Okay. Apply the concept like this. See, if you will apply the nodal analysis, means like a nodal analysis, V is equals to I into R. I1 is equals to V upon R. So you will get I1 is equals to V into G. 1 by R is G. What about I2? V upon XC. So I2 can be written as, and this XC value is minus J divided by omega C. So minus J omega C. So if we'll convert this, so it will be V I2 is equals to, if minus J will go upside, so it will become Vj, and this omega C is getting upside only. So I2 is equals to J V omega C. The omega C value is nothing but we can represent like this: J V BC, susceptance of capacitor. So susceptance of a capacitor is nothing but like inductor 1 by omega L was BL. For capacitor, omega C will be BC. These are the notations. You just have to remember. So this will be susceptance of inductor and this will be the susceptance of capacitor. So we are making your I equations is I1 plus I2. So I1 we got V into G plus J. I2 we got V into BC, and this I meaning V into Y, because I is equals to V by Z, and 1 by Z can be written as an admittance. So VG plus JVBC. So this will cancel out. So Y you will get G plus JBC. So for capacitor, what is happening? You can make it like this: Y at an angle theta, G at an angle 0 degree, and BC at an angle 90 degree. So what is happening? You have a reference point for G is on the reference only. What about BC? It will lead by 90 degree, and the combination of a G and BC will give you Y, and where will be theta will stay wherever the G means R part theta. So cos theta is what? Cos theta can be base by hypotenuse. So this is base and this is hypotenuse. So G upon Y will come, right? G upon Y will come. Everyone, it's clear? Prasanna, it's clear for you?
Yeah.
So G upon Y will come. So if you will solve this, magnitude of G is 1 by R, and Y means it will go upside Z only. We are getting this: cos theta is equals to Z by R only. Okay. So why we are getting G plus J BC. So what is the mod value of a Y? Root under G square plus BC square, or angle will be tan inverse BC by G, B into C, suffix G. It is not multiplied with, it's just a suffix, tan inverse BC. Okay. Okay. So in a capacitor, your capacitor in a parallel network, your capacitor is leading or lagging? Capacitor is leading or lagging? See, capacitor is leading by 90 degree. So for admittance, okay, so this part is leading. That's why we are saying, because we are getting a 90 degree lead for this susceptance. Okay, so always leading and lagging concept will come with respect point. At what respect we are saying. Okay, Sharon, for you it's clear? You are getting these things? Vaishnavi?
Yes, sir. Getting.
Okay. So yeah, now we'll go for parallel RLC network. Now you have a network like this. This is your R network, this is your L network, and this particular is your C network. C, L, R, and this is V of t. I am assuming some particular I of t current is moving. Okay, I of t current is moving. So if I of t current is moving, so if I of t, I am taking that is a I phasor, this will be I1, this I am taking I2, this I am taking I3. So guys, this is your XL, this is your XC, and this is your R. Okay, if you want to write in the form of admittance, you can write like this: G This is your minus J BC BL, and this will be J BC. This particular is U of t. So in the form of admittance I have written, because y minus will came j omega L is your 1 by j omega L your will give you the result of BL. So 1 by j means minus j, and 1 by omega L means BL. So that's why minus came. And for C we are having minus j by omega C. So 1 divided by minus j upon omega C. So this minus will go upside, so it will become j, and omega C will also go upside, so it will become omega C, and the omega C value is j BC. Okay. So if I am considering v of t is equals to Vm sine omega t. So what is the value of I1? I1 value is Vm by R sine omega t. This Vm sine omega t divided by R will give you I1 only, right? So sine omega t. What is your I2 value? Vm divided by j omega L sine omega t. And what is your I3 value? Vm divided by minus j by omega c sine omega t. So if you guys will convert this, you are getting I1 is equals to Vm by R sine omega t. I2 you are getting Vm by omega L sine omega t minus 90 degree. And I3 you are getting Vm omega c sine omega t plus 90 degree. This will go upside, it will become plus 90 degree. So for a phasor, this is your reference point. So see, I1 will be with respect to phasor only, because 0 degree is there. So you are getting your I1 here. What about your I2? Minus 90 degree. That means, yeah, it will lag I2 value. And what about your I3? It will lead. Okay. So there will be a resultant value, okay, for this circuit. If your I3 is greater than I2, the overall resultant will be I3 minus I2. And if your I2 is greater than I3, the overall result will be I2 minus I3. So suppose I am considering my I3 is greater than I2. So this value from this value, particular some part of this will get subtracted. So it will give some result here. This will be I3 minus I2, and the summation will give you your I current. If this is greater, here I am considering I3 is greater than I2. If I2 is greater, then this particular things will be minus by this particular thing, and it will give some results from here, and this will be I. So it will be I2 minus I3. And theta will, where will be the theta? If this particular thing is happening, for this, theta will be here. And if this particular thing is happening, so you will get theta particularly this side. Guys, clear? Guys, is this part is clear?
Yes, sir. So always you have to consider theta value with respect to the reference, right?
Yeah. Always you have to consider with respect to reference only.
Yeah.
Okay. So this was the concept of RLC. and write the note like we got this parameter right now, minus jbl jbc. This is your I2, this is your I1, and this is your I3. So this is your particular I current. So what you will get? Your I is nothing but I1 plus I2 plus I3. So I1 will be V into G, susceptance. G means 1 by R only, and I2 means V into minus J BL, and I3 means V into JBC, and I means V into Y. So take common G plus J, take common BC minus BL. Take like this. This V will get cancelled out. So Y you are getting G plus J BC minus BL. Okay. So if BC is greater than BL, that means this if BC is greater than BL, so you will get the positive result. Okay, positive result. If BC is lesser than BL, you will get the negative result, right? So it's depend upon the, if BC is lesser than BL, you are getting positive result, and if BC is lesser than BL, you will get the negative results. Okay, so effective work is happening in parallel RLC network. Okay guys, and cos theta will remain R upon Z upon R. Z upon R, power factor. Okay guys, everyone up to this, it is clear? Okay, if it is clear, then anyone is having any doubt up to here? Prasanna, you have any doubt? Rashna? Okay, then it's fine. Okay, so write one network. Now almost your AC network is done, so you need some see. Now assume you have a network like this. This is R1, this is L, this is R2. This particular you are getting as a capacitor C. Okay. This is V of t, and some I of t is flowing in this. So for what means this particular is one branch admittance Y1 I am considering, and this particular as one branch Y2 I am considering. So this is in parallel. In a parallel, what is happening? 1 by Z is equals to 1 by Z1 plus 1 by Z2. But if you go for a admittance directly, Y is equals to Y1 plus
plus y2.
y2. So what is y1? y1 is equals to 1 by r1 plus 1 divided by j omega l. So what it will give you? Or you can directly write like this. You can consider like this also, or you can consider like this also. What is the z1 value? r1 plus j omega l. So what is y1 value? 1 divided by r1 plus j omega l. Okay guys, you understood how I have written this? This is not correct. Okay, so for z1 you means for y1 you need overall z. Okay, overall z will be r1 plus j omega l, and the reciprocal of 1 by r1 plus j omega l will give you y1. Okay, what about this one? z2 r2 minus j divided by omega c. So what about y2? 1 divided by r2 minus j divided by omega c. So guys, if you want to bring this j omega l upside, means imaginary part upside, what you have to do? 1 divided by r1 plus j omega l multiplied r1 minus j omega l upside and r1 minus j omega l downside. Okay, so this is a, this is b, this is a, this is b. So a square minus b square formula. So r1 minus j omega l divided by a square, that will be r1 square only. J square will give you minus a square minus b square. So j square is minus will come. So minus will become plus. So omega square plus l square you will get. Okay. Rationalizations. We are doing rationalization, nothing else. So r1 square plus omega square l square. So y1 value you are getting this. What about this one? I have to do again rationalizations. Multiplied r2 plus j by omega c divided by r2 plus j divided by omega c. So what you will get? r2 plus j divided by omega c divided by r2 square and this square. Minus is there, so minus j divided by omega c the whole square. So j square minus plus j square will give you minus only, so minus will become plus. So r2 j omega c divided by r2 square plus 1 by omega c the whole square. So you get the value of a y1 is equals to r1 minus j omega l divided by r1 square plus omega square l square, and you get the value of a y2, that is r2 plus j omega j by omega c, that is j by omega c divided by r2 square plus 1 by omega c the whole square. What is overall y1 plus y2. Okay, so guys, you need to break this form, means r1 minus j omega l divided by r1 square plus omega square l square plus r2 plus j by wait just. So what I am telling, you have to break this term. So r1 minus j omega l divided by r1 square plus omega square l square plus r2 plus j divided by omega c divided by r2 square 1 upon omega c the whole square. Now separate the real part and the imaginary part. So if you'll separate the real part and the imaginary part, what you will get? R1 divided by R1 square plus omega square L square plus R2
Plus
divided by
R2 by R2 square plus 1 by omega square.
1 by omega c the whole square. And if you will take the j common, what you will get? This is your real part. And from this,
Omega L by
minus omega L.
square L square.
Minus omega L, na?
Sorry, minus omega.
Minus omega L divided by R1 square plus
R1
omega square L
omega
square
square L square.
plus 1 upon
Plus
omega c
1 by omega c by 1 by omega r square plus
R2 square plus 1
plus
by
1
omega c
omega
the
c the whole square.
whole square. Right? So this is your y part. So this is your real part and this is your imaginary part. Means this is your A part and this is your B part. So like this way you have to solve. Okay? This kind of a network. Okay guys? Any doubt? Anyone having till here? How we derive these things? If anyone is having any doubt, they can ask. See, let me tell you once again this part. Prasanna, you understood how this came?
Yeah.
Vaishnavi, you understood? See. This particular branch is your R1, this is your L. This particular branch is your R2 and this particular is your C. So what I am considering this as a y1 part and this as a y2 part. Overall Z is for this is R1 plus JXL. Not considering the omega form. And what about this Z1? And what about this Z2? R2 for y2. If I am considering for y2, I am considering R2. Z2 is R2 minus JXC. Right? If you solve this, you will get the same result only.
Sir, if you are considering that as y and y1 and y2, then z1 will be 1 by y1, right?
Z1 will be 1 by y1.
Y1.
Yeah, this I am considering as a Z1. This particular is a Z2.
Yeah, okay.
Okay, so Z1 will be 1 by y1 only. Okay, so Z2 is R2 minus JXC and Z1 is R1 plus JXL. So y1 is 1 divided by R1 plus JXL and y2 is equals to 1 divided by R2 minus JXC. Right? If you rationalize this, what you are getting? R1 minus JXL divided by R1 square plus XL square. And if you will rationalize this, what you will get? R2 plus JXC divided by R2 square plus XC square. Okay, I am not considering in the form of omega L. If you will put the value, you will get the same result. And now y1 plus y2, if you will solve this, what you will get? R1 divided by R1 square plus XL square plus R2 divided by R2 square plus XC square. J I am taking common. XC divided by R2 square plus XC square minus XL divided by R1 square plus XL square. Right? Okay? Right, this thing is correct only, or you are facing any doubt here? Prasanna, any doubt?
Not.
Not any doubt, na?
No.
Okay. So see, if you break this form now, if you break this form into two part, like r1 divided by r1 square plus xl square minus jxl divided by r1 square plus x2 square. So this is your
Real
g1
part.
g1 part, okay, and this is your minus xl divided by r1 square plus x2 square. This is your minus j b1 part in a short form. For same you will get g2 part plus j b2 part, okay. So these means y1 plus y2, how we are getting g1 plus g2 plus j, this is your b2 minus b1, okay. It's just a representation. b2 means the b2 represents for a capacitance and b1 represent for an inductor, okay. This is just a representation, okay. So this I wants to tell you means how to solve this kind of a circuit. So if you understood, then it's better. We'll move to, you understood now how we are doing this kind of a calculation, or still you guys have any doubt? Sarin, Vaishnavi, Prasanna, if any doubt you can ask, or we can move ahead.
Clear, sir.
Okay, great. So now it's a very small topic. Write it here. Z is equals to x plus jy. What is the meaning of this? If you want to make in the mod form, so this is zeta e power j theta. Zeta means what? Root under x square plus y square, and theta means what? Tan inverse y by x. This zeta is the modulus of mod of this root under x square plus y square, and theta is here the angle tan inverse y by x, okay. Okay, if you having a z1 is equals to like this x1 plus jy1, you can write like this zeta 1 at an angle theta 1, and if you have a z2 is equals to x2 plus jy2, you can write like this zeta 2 and angle theta 2, okay. So for addition,
So just you are taking a mod z as
this
right?
this zeta this is nothing but polar conversion.
No. No. I'm just asking you are writing zeta as
Mod value, I am writing the mod
Okay.
value. Zeta
Yeah,
is the
okay.
zeta is the mod value and theta is the angle, okay. So for addition, z1 plus z2 will be x1 plus x2 plus j y1 plus y2, okay. These things are basic concept. I think you guys know these things. Subtraction z1 minus z2. So what will happen? x1 minus x2 plus j y1 minus y2, okay. Number 3, multiplication. z1 into z2. So for multiplication, what will happen? Zeta 1 into zeta 2 at an angle theta 1 plus theta 2, okay. And what is zeta 1 and what is zeta 2? It is here only. Zeta 1 is root under x1 square plus y1 square, and zeta 2 is root under x2 square plus y2 square, and theta 1 and theta 2, theta represent tan inverse y by x. So substitute this value, you will get, so zeta 1 zeta 2. For division is z1 divided by z2, that is zeta 1 divided by zeta 2 at an angle theta 1 minus theta 2. Reciprocal 1 by z means 1 upon zeta. Angle will be minus theta. For square root, root under z means root under zeta, angle will become theta by 2. Angle will be divided by 2. Okay, this is your magnitude part. Angle will be divided by 2. So suppose you having a z root, that is z to the power 1 by 2. So if you want to make in the representations of a theta, that in the polar form, so it will become root under zeta at an angle theta by 2. Similarly, if you have a z to the power 1 by 3, so it will become zeta to the power 1 by 3 and theta will be divided by 3. Okay. Conjugate. So conjugate means z is equals to x plus jy. What is the meaning of a conjugate? If it is z is equals to zeta at an angle theta, so z conjugate means x minus jy. Imaginary part will become minus, and z will become zeta at an angle minus theta. Okay. Now if you having some if you having z1 multiplied with z2, what you will get? Zeta 1 e power j theta 1 into zeta 2 e power j theta 2. What will be the overall result? Zeta 1 zeta 2 e power j theta 1 plus theta 2. So that's why we are getting zeta 1 zeta 2 at an angle theta 1 plus theta 2. Okay. So what is the meaning? Means z to the power n means what? Zeta e power j theta to the power n, and this can also be written as zeta to the power n into e power j n theta. So that's why z to the power n, it's coming like zeta to the power n angle n theta. Okay. Is this concept is clear for everyone? Prasanna, it's clear?
Yeah.
Okay. Now, if it is clear, then solve this question. You have a network. Okay. Wait. You have a network. Why it's not working? Yeah. So you have a network of inductor, and there is a resistor, there is a capacitor. Okay. This is L, this is R, this is C. This particular is given as a 13 ampere. This is magnitude. You should always take the magnitude. The angle is not given. This is V of t. And here it is given that current is 24 ampere, and here it is given 5 ampere current. You need to find the current of IC. What will be the current of IC? Guys, solve it. You have a 2 minute. This is just a simple KCL. So what will the current of IC? tomorrow or day after tomorrow your AC circuit will be completed. Then we'll move for a next chapter, that is theorem. Prasanna, what will be the answer? You have the branch current, na? So what will be the current of a IC? Vaishnavi, Sharin, Guna. Prasanna, why are you taking so much time for this?
It's 12.
How much?
12.
12.
Yeah. I see value.
IC value will come 12. Sure.
Yeah.
How you did 12? You did like this. 13 is
13 equal to under root of
under root of.
5 square plus IC square.
Oh, you have considered root square value like this. See,
Yeah.
okay, that is great. Means if you think like this, then it's fine. I thought you guys will think like this. 13 is coming. That means this branch current, net incoming current, you will directly add it. So this is not going to happen here. Okay, 13. If 13 is here, and these all are incoming current, so 13 will not be equal to, that is not will be equal to outgoing 24 plus 5 plus IC. 24 plus 5 is 29. 29, if you will subtract 13, so 6 1, so minus 16. So this is not a correct answer. Okay, but how to solve these questions? For this you need to know that this is your I phasor. Okay, this is your I1 phasor, this particular is your I2 phasor, and this particular is your I3 phasor. Okay, so what is the modulus value of this I? Root under I1 square plus I2 square plus I3 square. It is like this. Okay, modulus value. So what the value is given? 13 is given.
13.
13 it's given. So square of 13, and this you will get
115.
I1 square plus I2 square plus I3 square. Okay, so 169, right? 169, and what is the square of 24? 576.
576.
576, and what is this square of this 5?
5.
25. So do this and get the result. Means you have 169 minus your I1 is 576 minus 25 under root. It will give you I3 value. So I3 value, what you are getting? Solve this and just tell me the answer. What you are getting? I2 value? And see guys, you cannot do like this also. Why so? This is also wrong. See, why so I will tell you. Okay. See, you, for this kind of a network now, what I told you, you remember, for this network, this is what? This is RLC network. Okay, what we were getting for RLC network? I is equals to IR plus J IL minus IC. This we are getting. So where is your IL part? This particular is your IL current, and this particular is your, or either you can write IL minus IC or IC minus IL. It's depend upon the value. So like earlier we discussed these things. I will tell you. From here you have to take it. Yeah, this particular things. So what you are getting, see this. Okay, so in this what we are getting, we are getting our I is your resistance part I1 plus J is coming, and this is your IC current minus IL current. Okay, you have to remember this part. IC minus IL is happening if you are writing plus sign here. Okay, so see, so IC minus IL will come. IC minus IL will come. Even if you are writing IL minus IC, the answer is not going to change, but this is the correct notations. So you know the IR value. IR value is how much? 24. And you know the value of IC. IC value don't know. You know the value of IR value is
IR is 5.
IR is 5. Okay, correct. IR is 5. IC value you don't know, you have to calculate the IC value, and IL value you know 24. Okay, and I value you know 13. So 13 is equals to 5 plus J IC minus 24. Now solve this like 169 25 root under IC minus 24 the whole square. So if you will solve this, this will come 169 minus 25 will be 144. IC minus 24 the whole square. Square root of this is 12 plus minus 12, and here also plus minus. You are getting IC minus 24. So now if this is going to add in this 12 plus 24, you are getting one IC value is 36, and one value you are getting, if you are subtracting this, so you are getting IC value is 12. So two value is coming, 12 or 36. Okay, so IC value will be either 12 or 36, not 13. 13 will not be the correct answer. Prasanna, got it or not? Have you understood how this value came?
Yeah.
Or any doubt here you guys have any, if any doubt you can ask, means how these things is happening, or it's crystal clear this concept. Okay, so you understood now how the values are coming. So we are getting like this. So you have to consider the inductor and capacitor, because this will also have a J term and this will also have a J term. So you cannot simply directly like add this. Okay, so because means the formula is valid for A plus JB, root under A square plus B square, and here if you will take the common, you will get IC minus IL term. Okay, so that's why we have to subtract these IC from this minus 24, and you will get the result like this. Okay, if you understood, then it's fine. Okay, now do one thing. Question number 2. You have inductor parameter, that is L, that is R, that is positive, negative 2 volt. This is positive, negative VL, and this is given as positive 20 volt peak to peak. You need to calculate the value of a VL. How you will calculate? Peak to peak means -20. So peak to peak, that is peak to peak. So means like the combinations of this is 20. So peak to peak means your VM value, your VP value is 2 VM. This is means the amplitude of this plus amplitude of this. This is known as peak to peak value. So your 2 VM value is given as a 20. So VM value will be 10, and here 10. So 10 plus 10, 20 is coming. So that is known as peak value. Okay. So your that means you having the supply of 10 sine omega t. If you convert this in the RMS value, what you will get? Vrms is equals to 10 upon root 2. Okay, right? For a series network, how was the result? Overall V was VR plus J VL. Remember this one, V is equals to VR plus J VL. Inductor, remember or not? We are getting, because see, the same current will flow, so I into R result will come, but here the thing is JXL, so that's why 90-degree leading will come. So that's why we are writing JVL. So you know the value of this particular value, you have to convert, always you need to convert into the RMS value. So you know this is 10 root 2. So overall V can be written as VR square plus VL square. So V is 10 root 2. Okay, take the square, you will get VR square plus VL square. So 10 square by root 2, what you will get? 100 divided by 2, that is 50. And VR is given as 2 volt, that is 4, plus VL the whole square. So VL value will be
under root 46.
under root 46. Understood or not? These things understood, or any doubt? Prasanna, any doubt?
No.
Okay. If no doubt is there, then it's fine. So write the another question. Question number 9. In the below given network, wait. Yeah. In the below given network, find the power factor of the load and power dissipation in the load when the load resistance are in 5 ohm. Okay, so suppose means you have a network like this, R1 positive, negative, this is V2, this is positive, negative, VR, and this is positive, negative, VL. Now I am considering this is our load, considering this is a positive, negative, V3. Okay, so in this circuit it is given positive V1, and suppose I current is going, okay, and the value of a V1 is given as 220 volt, and the value of a V2 is given as 122 volt, and the value of a V3 means overall load voltage, V3 is given as 136 volt. So a load resistance is also given, load resistance is 5 ohm. Okay, and you need to find the power factor. So tell me one thing, load in the given network. So this is your load is given like this, R plus L combinations, and the resistance value is given as a 5 ohm. Okay, so you need to find the power factor of the load and power dissipations in the load when the load resistance are in 5 ohm. Okay, tell me one thing, if you know the V3 value, V3 means what? If you will apply the KVL, so V3 will be what? VR plus JVL, because it is the inductor. Okay, and what about overall V1? V1 will be V2 plus V3, and if you write like this is inductor, this is resistance itself, so V2 plus with V3 value VR plus JVL, you will get V1 plus V1 is equals to V2 plus VR plus JVL, right? So V1 you are getting like this, V2 plus VR plus JVL. Okay, so now see, Prasanna, see, V1 value is given, Vaishnavi, you see please, this V2 value is given, V2 value is 122 and V3 value is 136. Okay. Okay. Yeah. So you know the V1 value, you know the V2 value, you know the V3 value. Okay. So how can it will be solved? Like it can be solved. How can it can be solved? Okay. How these questions can be solved? So you have V1 value, you have V2 value, you have VR value, you have JVL. Okay, and this particular resistance you also have, this particular resistance you also have. So if you'll apply the KVL, means like we having the resistance of this, and we having the V2 value, that V2, this particular V2 value we having. So can you find the value of a V3 VR value? See, V3 is VR plus JVL. V3 mod will be root under VR square plus VL square. So V3 value we have 136. So V3 value we having 136. If you'll do the square, VR square plus VL square, and you also have the V2 value, that V2, that VL is nothing but let me see. Yeah,
It's a combination of V3.
no, let me check it. Okay, wait, so I drawn wrongly. See, yeah, you are saying correct only, means see we have a figure like this. There is a means a very good concept. So if you understood this, you can solve a lots of question.
So they're asking power factor, right? Can we represent in a phasor form and
We can
find
represent,
out the angle?
we can represent in the phasor form. That is that we can, that we'll do. But the thing is that there is one concept what I want to teach you. This particular is L, this is R, this is positive negative VR, this is positive negative VL, this is your V1, and this is I, and the value of a V1 is given 220 volt. Okay, and the value of a V2 is 122 volt, and the value of a V3 is 136 volt. So this particular is your V3 overall combination. So V3 we are having as VR plus JVL. Okay, so what you are saying that we can represent this in the form of a phasor form, that is correct. What you are saying, that it's correct. If you will represent in the phasor form, it will be, but we can solve these questions without phasor also. Yeah, it's good to approach with a phasor, but see, if you have the V1 value is 220 volt, and this V3 value is 136 volt, and V2 value if we having a 122 volt. So we having the combination, means like, see, 220 volt, 122 volt and 136 volt, and this 136 volt is the representations of VR plus JVL right now. So if you'll go with the phasor form, suppose this is your reference point. Okay, if you'll go with the phasor form, so where will VR will come? VR is the resistance
With
part.
respect to the reference one.
With respect to the resistance reference only. So VR will come here only. Okay, and where will your V2 will come? This is also resistance. So
Yeah.
it will come. V2 will come here, somewhere here, because V2 value will be high, somewhat high. And what about your VL? This VL, it will
Lead
lead by 90 degree
90 degree anti-clockwise.
anti-clockwise. It will lead by 90 degree VL. Okay, and what about V3? V3 is the combination of VR plus VL, right? So we are having a VR value here, and we having a VL value here. So somewhere here you will get the V3 value. Okay, and what about your V1 value? V1 value is the combinations of VL and that V2 that V2 and
V2 and
V2 and V3. So you will get your V1 here. Okay, like that you want to tell, na? So
Yeah.
so here we are having a phi angle. Okay, and this is your I current only, because it will be in the same phase with resistance. Okay. Okay, so what we are getting from here? Here we'll get one important result. V1 is equals to root under V2 square plus V3 square plus 2V2 V3 cos phi. Okay, V1 is this one, this particular. Okay, V1, V2 V3. So see, this is your V2 and this is your V3. So this is one formula, means you need to know, means like you have some, suppose you have some V2 here and you have some V3 here. So overall the net phasor what we are getting, that is assuming a V1. So V1 will be root under the square of this and the square of this, V2 square plus V3 square plus the multiplications of this
2v2
2V2
with the cos
V3
phi.
into whatever the angle present in this, cos phi. Okay, we know the value of a V2, we know the value of a V3, we know the value of a V2, we know the value of a V3, we know the value of a V1. So we can calculate the cos phi value, right? 220 square is equals to 120, 122 V2 square plus V3 value is 136 square plus 2 into 122 into 136 into cos phi. So what is the value of a cos phi we are getting? 0.45, and it will lag. Why lag? Because inductor is there. So in a inductor, overall means it is the combination of resistor and inductor. So that's why it's lagging. Lagging what? Your current is lagging the voltage. Lagging means, lagging here, lagging means what? Your current is lagging the voltage. Okay. Or how can you, or you can solve these questions like this also. See, this particular is 90 degree. So cos phi is B by H, base by hypotenuse. So base is your VR and hypotenuse is your V3. So cos phi will be, VR value will be VR. We need to calculate the VR value, and V3 value we know 136, and we know the phi value. Cos phi value we know that it came 0.45 into 136. So VR value, we get the results of a VR value, that is 61.2 volt. Okay, now you need to find the power. So power is nothing but V square by R. So load, for a load, dissipated power. So because we know, we had studied the average power of inductor will be 0, so we don't have to worry about this. We only will consider the power across the resistor, right? Power across the resistor. So we know the voltage of this resistor, that is 61.2. So 61.2 whole square divided by resistance value 5 ohm, we will get 749.08 watt. Okay, and we have one results like this is your one method. Another method, we can solve this question with V3 square is equals to VR square plus VL square. Okay, and V1 square is equals to V2 plus VR square plus VL square. Okay, see, suppose means like you got up to this, up to here, you got it, means how this came, Prasanna.
Yeah.
See, this is very much important, means like see how we are drawing the phasor. It's very much required, means let me tell you once again. See, this is your reference point. Okay, here we having one register, and here is the combination of resistor and inductor. Okay, and here you having the overall voltage, net voltage, that is V1. That's not working. Here you having the net voltage, that is V1. This one was V2, this particular was VR, and this particular was VL, and this overall they have considered as a V3. So if you are drawing for this V3 network, V3, because the current will flow the same in this circuit, correct,
Yeah,
Prasanna?
even increase current will be the same.
Same current will flow. So, and I am assuming the current has been taken as a 0 degree angle. Okay, I am just assuming, nothing is given. So this is my I. So if I will multiply it with this particular resistance R, I into some R value, so what you will get? You will get VR value. Right, Prasanna? VR value.
Yeah.
I is getting multiplied with some, it may extend, but I am drawing. So VR value we will get. Okay. And you are getting also the thing, means you are getting also what? You are getting I into JXL. So 90 degree anti-clockwise with reference.
Yeah.
So it is 90 degree with reference. I am taking this as a my VL. Okay, right? We can draw like this, na? This is my VL, means I am considering this. I'm just drawing for a VR and V3 part. So VL we draw, VR we draw. So we are getting a results of V3, right? Up to here it is clear.
Yeah.
Okay. Now can anyone tell me, means like we are getting a V2 part, I into V2. So V2, where V2 will lie? V2 will also, it will lie somewhere, na? So V2 will be, suppose I am taking V2, because this is the register part. So V2 will also lie in this, correct? Particularly in this part. Correct? V2, because this the same current is coming and you are multiplying with the resistor, so V2 will become in the same part. Correct? Now if you want to draw the phasor, means like suppose you want to draw the you have drawn the V3, you got the results of a V3. Now you need to know the value of a V1. So V1 is what? V1 is nothing but V1 is V2 plus V3, na? V1 is nothing but V2 plus this particular V2 plus V3, right? So earlier we drawn like this. See, we have drawn this phasor like this. We have drawn this phasor like this. This is we consider as a VR part, and this particular we had extended and we had considered this as a V2 part. V2 part. And from VR we are taking, supposing this particular, it is our VL, means considering from this angle, and by joining the head and tail, this is our head and this particular is tail, or we can say from tail to head we will get the V3 part. Okay, so guys, means I having one doubt, means like you know the head tail concept of a vector. Prasanna, you know the head tail concept of the vector? Prasanna, you know the head tail concept of the vector? See, suppose means like a vector v1 is here, and vector v1 is the addition of a vector v2 plus v3. Vector v1 is the addition of a vector v2 plus vector v3. So you have to represent in the form of a vector v2 plus v3. So suppose this is your vector v2, it is going this side, this is your v3, this is your v3. So one vector completed, we took the another vector, some particular with some angle, whatever the angle will be this, and the resultant of this tail to this head will give you v1. So that's why in this question, particularly in these questions, they had mentioned the vector like this. They have taken this particular vector as a VR vector, V2 vector, VR vector is this, and the VL will lead with reference we are checking. So VL will lead 90 degree. So we got the result like this, and we connected the tail part and head part. So that's why we are getting this as a V3 part. Okay, so this V3 is done. Okay, now you know the V3 and you know the V2. So you have to extend, that is a parallelogram theory. So you have to extend the line like this, like this. And whatever the things you are getting, this will be your V1. Prasanna, you understood means what I am trying to say, or still having means facing this is difficulty, this one is a difficulty, this diagram. If you are facing, you can say me. I will try to explain the things in a much better way. Prasanna?
Yes, sir.
Yeah, what I am saying, you are understanding means how this diagram is.
Yeah, got it. Yeah.
You got it. So can you explain me how you are getting this diagram?
First, we have to draw for V1
Okay.
with respect to the difference.
Okay. First we have
And
to
next we
first we
draw-
have to draw to the V1 or V2 or VR. How you are drawing V1? How V1 will not come, na? V1 is the summations of a V2 plus V3. So how you will draw the V1 first?
Sorry. So first V2,
First you will draw V2, okay?
and then V2, and then V1 is a combination of V2 plus V3.
No, you again said wrong. See, first you have to draw in this particular question. First you have to draw the VR diagram. Okay, VR, the load resistance, load voltage. Okay, there you have a VR and VL. Okay, so VR and VL. This is your VR. This particular is your VL. Okay.
So first we can draw for V2 also, no, with respect to the reference only.
You can draw. Okay, you
Just
have
for
drawn
reference.
you have drawn V2. Chal. Okay, it's fine. Then
Yeah.
When you had
Next
drawn,
V3.
when you have drawn V3, V3 it's okay. V3 is the VR plus V.
V3.
V3 is VR plus VL. It's fine. Then
Next, V1 is combination of V3 and V2.
okay, okay. So V1 is the combinations of V2 and V3. So you means you are understanding these things.
The concept I got.
You got the concept now. Why this line is coming, particularly this particular line is coming. So we are taking these combinations.
Yeah, to connect V2 and V3, we're just drawing
Yeah,
the
we
line.
have means see, there is a head tail concept in this vector. Okay, so means like see, suppose I am drawing if I have to draw, you have a reference point. Okay, if you have a reference point, so you are drawing VR you draw. Okay, now you had connected, now you know the lagging concept, that is your VL is lagging by 90 degree with reference. But you need to know the results of VR plus VL. So
Gives you V3.
yeah, so these particular line na, this particular
Which
line,
connects the head and tail part.
yeah, head and tail part. So how we'll connect the head and tail part?
By drawing the line.
That's why. How? So we have to shift this vector toward this side. Okay, this vector is shifted towards this side. Now you have tail part, now you have head part. Now if you will connect tail to head, you will get V3. Understood? Vector can be shifted. This vector can also be shifted upside, downside. So you can do like this also. If you have VL, you are making VR upside and you have a head tail path. So from tail to head, you are getting V3. We can do like this also. Understood? So that's why means for drawing here the hidden part is this. This is your hidden part. This is also VL. Okay, with respect to this. But we had shifted particularly for drawing our V3 because we are deriving the formula. So we just shifted this side. Okay, so this vector is shifted particularly this side and your head and tail is connected. If you are drawing like this is your VR, this is your VL. So how you will connect your head and tail? So head and head is only going to connect now. So that's why we need to shift. Understood? Prasanna?
Yeah.
So in this so in this if you want to draw the V3, this is going to shift here. Okay, this particular what we did in the previous question. So this is shifted here and then we have to draw like this. Okay, this we cannot do. Okay, now you have a V3, now you have a V2, make V1. Okay, I hope you got it what I am trying to say, because this concept is very much important. Okay, Prasanna, is this clear?
Yeah.
Okay. And means see here phi angle is your power factor angle. Okay, so power factor angle means what? You have some I current at an angle 0 degree, and this is your voltage. You are seeing this as a load na, so you have to see the angle between your current and your voltage, load voltage. So your load voltage is V3. So that's why so V3 we have this particular is your V3. So we are seeing the angle between V3 and I, and V3 and I angle it's giving phi. So that's why it's becoming a power factor angle. Okay. See, if this is RL load, RLC load will also come. So what I am saying, if this particular is your RL load, so if it is RL load, so R plus JXL, that means you will get some Z, means in this branch I am not considering in this R is not considering, you will get some Z, particularly angle theta. Okay, and means you are getting some V at an angle, here V at an angle phi, or you are having some I at an angle 0. So these I and this Z, if you will multiply, what voltage you will get here? I into mod Z at an angle theta. This will be your V3. So V3 is at an angle, how much angle? Theta angle. And your I is at an how much angle? 0 angle. So you have to see the angle between your current and your load voltage. So load voltage, this is your reference point. Okay, so load voltage, from the load voltage, this is your reference point. From reference point, how much? V3 you are getting at an angle theta. And what about the current? Your current is this only. So then this theta will be your power factor angle. Power factor angle is generally whatever the load voltage, the angle between your load voltage and the current, whatever the current the load is consuming. So what is the angle difference between your load voltage and your current? You got this concept? Prasanna, you got this concept?
So load side we are considering as V3, so we have to take the angle between V3 and I, right?
Yeah, because here the load is the combinations of R and L.
R and L.
Yeah, that's why, means you have to take the whatever the angle difference between your current and your load voltage. So that's why we are getting the angle, this theta angle. Okay.
Yeah.
Okay, so you will understood while doing the questions and all. We'll have lots of questions, lots of problem for this kind of concept. Okay, I hope you understood this question, because we took a lots of time for discussing this question, particularly this question, because it was very important. That's why. Understood?
So without phasor diagram, how can we solve this? Other method.
You
Other method without drawing the phasor.
I will tell you the other methods we'll discuss tomorrow. Okay, the other methods.
Yeah.
So other method is nothing, means we just have to assume that V3 is equals to VR square plus VL square, that the modulus concept, and V1 square is equals to V2 square plus VR square plus VL square. So we got the two equations. We need to solve these two equations and we'll get the results.
Yeah.
directly.
Okay.
Okay, so we'll solve it tomorrow.
Yeah.
Okay.
Okay.
Okay, good night. Winding the session.
Good night.